Hello and welcome back to Calculus 3. This is the second part of our lecture on curvature and normal vectors. So now we are going to talk about the principal unit normal vector, which is going to be 90 degrees to the tangent vector. So when you take a look at the curvature, some curve like this, and you pick a point, if you have a tangent vector going this way, the normal vector will be 90 degrees to that tangent vector pointing inwards. Remember how you have the acceleration point inwards? Well, that was the normal vector actually. It was not a unit vector, but so you have the position point towards the point, then you have the tangent, which is velocity pointing one way, and then the normal vector pointing, which is acceleration pointing inwards. So now we are going to have mathematical representation for all of that. So let's talk about the definition, and then we are going to have the same deal as earlier. Definition is one formula, and then to compute there will be a formula in respect to parameter. So let R describe a smooth curve parametricized by arc length So we are using arc length again to understand the concept. So the principal unit normal vector at the point P on the curve where curvature is not zero, so curvature different than zero, is n hat of s, that is the derivative of the vector, unit tangent vector, divided by the magnitude of that vector. So it's just the change. It's a unit vector, right? It's a vector divided by its magnitude. So you have the same vector. Now, what's a normal vector? Normal vector, right? What's acceleration? It's change of velocity. So the normal vector has to be the change of the tangent vector. That should be clear. And the equivalent formula is to say 1 over k dt ds. Again, we do not use any of these to compute, we just use it to define the concept. So as much as you have that the acceleration is a change of velocity, and I said that the acceleration is equivalent to your normal vector, velocity is your tangent vector, then this definition makes perfect sense because you have that the normal vector is the change of the tangent vector. Excellent. And you have it as a unit, which means it will be divided by its magnitude. So that's that. Now we're going to use the same trick as earlier to multiply top and bottom by 1 over dt. And when you work out that calculation, you come up with a formula which you guys would use to calculate the normal vector in terms of t. And that formula is change in t dt. So it's t prime hat divided by the magnitude of t prime hat So this is what we use to calculate the normal vector. So use this formula to calculate unit normal vector n hat. These calculations can literally take forever. Because you are talking about the second derivative and vector valued functions, and if it's a 3D, then it's just... So let's do a vanilla example, and then one of the annoying examples, and that will be it. And then you can use this vector to decompose. If you read in a book, you can use it in physics to decompose your acceleration vector into normal component and tangential component. So tangential component of the acceleration vector would be the one with the t, and the other one with n. So if you are interested in these concepts as they apply to physics and other things, you can just read extra examples and use. Let's try to find something civil first. With the 28, even though it's a 3D problem, it should not be too bad to compute. So this could be regarded as one of the cheaper problems. Cosine t, 4 sine t, and then 10t. So this is our helix. And we want to calculate the unit normal vector at every point of every point. They point all towards the center along the line in. So, well, actually I can draw a helix and then just point all of the normal vectors inside. It's kind of hard to see, but they're all pointing towards the z-axis because we are wrapping around z. So all of these are n hats, and they happen at different points, so they're in different location, obviously. We need r prime, so we can get t, so we can get t prime, so we can finally get n. One more time. We need r prime to get to t prime, to get to n. So r goes to r prime, goes to t hat, goes to t hat prime, goes to n hat. Do we understand why this can take 40 minutes of your life? Look at the string, right? So let's go with r prime. Guys, the r is given, not r prime. I don't know why I put an r prime here. It's not supposed to be r prime, it's supposed to be r. R is given. You come up with r prime as your first calculation. So negative 4 sine t, 4 cosine t, and then 10. That's your r prime. We also need magnitude of r prime so that we can compile unit vector. So magnitude of r prime is the square root of 16 sine squared t plus 16 cosine squared t plus 100. That's the square of 10. Now you factor out 16, and then sine plus cosine is 1. So this works out to be 16 plus 100 is square root of 116. So I have my t hat as r prime, which is the number we have up there, the vector we have up there, which is negative 16. You have 2 or 3 quotient rules to t hat. If you just give this root to each one of these components, your t hat is negative 4 over root 116 sine t, and it just becomes a constant that you shovel around, so it's not a big deal. We'll see some of the calculations later. cosine t, and finally 10 divided by square root of 116. Now, some of you will say, do we have to rationalize? Do we have to, just do as you must. But, So we calculated t. Next order of business is to calculate t prime, because t prime is used as in calculation for n. So t prime over magnitude of t prime. So I have to come up with a t prime now. And that's luckily easy because these are just messy constants. So derivative of sine is cosine, so I have negative 4 over square root of 116 cosine t. Then I have negative 4 over root 116 sine t. And then I have a big fat 0 on the z because it's just derivative of a number. And now I need the magnitude of t hat, which would be the square root of all of these squared. So that's going to be 16 over 116 cosine squared t plus 16 over 116 sine squared t plus big fat 0 squared. I don't need it, so I'm just going to get rid of it. And when I factor out 16 with the square root of 16 over 116 over there, you get sine squared plus cosine squared, which is 1. So this turns into a square root of 16 over 116, which is 4 over square root of 116. Okay, we can leave it there. Great. It's just massive calculations, so you can follow along in the notes, I guess. I don't know. Hopefully it reconnects. Issues with bandwidth today. You never know, right? Each day. Sometimes it works, sometimes it doesn't. N hat is t prime of t, right? T hat divided by the magnitude of t prime t. So we have our t prime, which is this mess over here. That goes in the numerator, divided by 4 over square root of 116, which is the magnitude which goes in the denominator. Now, through the magic of copy and paste, come on, I will add this vector without too much writing. I will add the vector where it belongs. And then we see that these 4 over root 16 cancel everywhere, giving us a beautiful normal vector of negative cosine t, negative sine t, and 0. Yes. Great. And we see that it should be this, guys, because remember that the helix is circle, and the acceleration vectors should be pointing inside. So this should match what we had earlier, and 0 component on z, because they all point in plane inside towards the z-axis as the acceleration vector for the helix motion. This is considered a gift of a problem. You can get it easier. The example we had earlier with ln is worked out beautifully, right? We worked out into that 1 plus tangent squared, which gave you secant squared, which canceled the square root, which got secant. So this can be a little bit prettier than this, but this is as pretty as it gets, right? Another example. What do we have? 55 minutes? It's enough. Just kidding, don't have a heart attack. Let's see what else nice we can find. Ooh. How about a two-dimensional problem of R being t squared comma t? This is problem 33. What could possibly go wrong? Right? It's just t squared and t. It's a two-dimensional, it's just t squared and t. It's not It's not a helix with 3's, right?
You're laughing
Because I know that I opened the gates of hell, and just let's see how this works. All right. How about you try this on your own for like 18 seconds? See, there, you know the drill, right? R goes into R prime, goes into a T hat, goes into a T hat prime, goes into N hat, right? So, and you have the long list of. So get R prime is a joke, right? It's not an issue. Come on.
Yes. Yeah.
Well, it's
Yeah, that's generalized. I feel like this is gonna get ugly later.
yeah. If you put me down for two right now, I think I'm gonna be. Remember that thing from the CEO I was sitting thinking about the right one, and then
T hat, that's the unit tangent next to it.
without breaking this like.
So the vector of the tangent line at that point. Yeah, basically.
I just like most.
Oh,
But then, are you now going to have to
denominator over numerator plus over the derivative of the bottom over the bottom square.
You're trying to work it out to make it.
I just remember it as
Oh, so if you're going back to the numerator, so if you're doing the numerator times the denominator, no. We'll probably decide what you have to take. Okay, high zero minus low high over low square.
Brilliant.
Oh, derivative log over t.
Calculus party, huh?
What?
Calculus party.
I got to duck on 33.
Got stuck on 33.
Yeah, it took me a while to figure out what that number was. It's too high.
It's 30, that's something. 32.
Yeah, now I count again.
And right before 34.
If I remember my fingers.
Oh,
It's too high.
yeah. Right, this joke has the highest number I've seen in my calculating course when I took it.
So high d would just be
That was the highest calculation. Because everything is this.
Don't look me over.
No,
Not this. Just
not this one.
cosine.
T squared is T.
No, this one's gonna be.
oh.
This one is terrible. But it looks so nice, right? Let's dance. R prime is 2t1. And the magnitude of r prime, which we need so we can compile t hat, is going to be the square root of 4t squared plus 1. There is nothing you can do to simplify that. That's it. So your t hat is going to be 2t1 divided by the square root of 4t squared plus 1, which creates this vector 2t divided by the square root of 4t squared plus 1, comma 1 over 4t squared plus 1 root, right? And now we need to take derivatives of those to come up with t prime, and then use them in the square roots, right, for magnitude to come up with t prime magnitude, and then put those two together to come up with n. Such a nice problem, right? All right, so what do? I need t prime hat. So the t prime hat, I have, technically, I can real quick recast this as 2x, just to take the derivative, square root of 4x squared plus 1. I have a very quick way of taking these derivatives, because this is a quotient rule with a chain rule on the bottom with a square root, right? So the way you take this derivative quickly is you select this like that, you push the math button over here, and you select differentiate, and it gives you that's how you fast differentiate these things. Otherwise you sit there for like 25 minutes and figure out, which is the reason why we are not going to sleep here tonight, right? We're all going to get to go home. So the derivative of the first component is 2 over 4t squared plus 1 to the 3 halves. And then you turn this off, and then you replace this 2x by, by 1, and then you rinse and repeat, right? Take that, push math button, and then differentiate, and it's negative 4x divided by 4x squared plus 1, 3 half. This is also the good time for me to spew some more hate toward the Crapple products. Do this on your eye, whatever, in a free software that is distributed with the device, because we all know very well that they have nothing to offer. T's, these are supposed to be T's, T and a T. So I took the derivative, well, the tablet took the derivative for each one of these, and I have them down there as a T prime. Now the next one is the magnitude of T prime, and that's going to be the square root of all of these squared. So I'll have 4 over 4t squared plus 1 cubed, because this divided by 2 was cancelled because there was a square there, plus 16t squared divided by, and it's the same denominator of 4t squared plus 1 cubed. So to simplify this one, I'm just going to start this one here because I have to go back. That's when I'm going to pick up my vector. All right, so now I have a square root of 16t squared plus 4 divided by 4t squared plus 1 cubed, which is the common denominator as you add both of these. Now, do we all see that we can factor out 4 in the numerator? Isn't that going to be nice? Of course it's going to be nice, right? When you factor out 4 in the numerator, it gives you 4t squared plus 1 divided by 4t squared plus 1 cubed. Do you see what happens now? it simplifies, right? Because the 4 jumps out in front as a 2, and then this one cancels with one of these, so you have square root of 1 over 4t squared plus 1 everything squared. Well, now the square root kills the square, and the t hat prime simplifies nicely to 2 over 4t squared plus 1. So now n hat is a t hat prime divided by the magnitude of t hat prime. Now we know that the t hat prime magnitude is 2 over 4t squared plus 1, right? So that's the easy part. Now I have to go up there where I had the star equation. There it is. So it's going to be 2 divided by 4t squared plus 1 to the 3 halves, comma, what was the other one? Well, now we get to cancel stuff. The 2 cancels. You get your negative 2t over here. And the denominator will knock out these 3's up there, so it's just going to be 1/2 left, because this is 2 halves. Exponent is 1. So 3 halves minus 2 halves is 1/2 everywhere, so it knocks out that 3. From there, it's just algebra. So n hat is equal to 1 divided by 4t squared plus 1, and it's a square root because 1/2 is left, comma, negative 2t divided by the square root of 4t squared plus 1. Ta-da! Compute this at t equals 0, right? You get 1, 0 vector, right? That is a normal vector. If the t, right, is given to you, then you have to go 1 step extra to calculate the value of that vector. And that would be, right, to t equals whatever the number is given, compute the whole thing, and get the vector, which would be the normal vector. Now, normal vector here has a hat, signifying that this is a unit vector. So let's say you care about this and you want to check. Well, you need to run the magnitude of this thing, and when you run the magnitude of this thing, if it works out to be 1, well, it's probably good because it's a unit vector, and the property of a unit vector is the magnitude must be 1. Now, luckily, this problem is easy enough for us we can do that mentally. We don't have to write anything down. We know that to find the magnitude, you square both of these and add them. When you square the first one, all you did is you kill a root. When you square the second one, this becomes 4t squared, and you kill the root. So you have 4t squared plus 1 is a 4t squared plus 1 divided by the common denominator of 4t squared plus 1. They cancel completely down to 1, so we know it's good. So after, now where did I save considerable amount of time and saved myself from making silly mistakes and stuff? I saved because I cheated, right? The tablet took those derivatives for me, right? So I spent 0 time working out those quotient rule, right, with the chain rule and all of the other things that are terrible in there. So that procedure, right, to take those 2 derivatives would take some time, and simplifying each one of those to what I have here as a simplified version would take some time. So this problem could easily go up to 30-minute calculation when you are doing it carefully, and so on. Is the concept hard? No, it's just a normal vector, right? It's a normal vector which is 90 degrees to the tangent vector, and tangent vector is 90 degrees to the r vector, and they all represent the motion if you want to use them in that aspect. You can use them in other aspects as well, right? Which is, let's say, your blade, the propellers, right, in the fan would turn one way the wind pushes forward. We're going to see those things, right? So it's going to be the normal to the surface. So you have these concepts easily available for you to find them around yourselves, right? But the trick is that, calculation can take some time and be painful. So that's curvature and normal vectors. And this concludes everything that we need to know for the first part of Calc 3. Now you pick to have exam next week on Tuesday, so all of these would be featured on the exam. We're going to have the review on Monday where you will bring on questions and so on. Today I can just tell you that you are expecting to see, one problem for t, one problem for curvature, one problem for normal vector, one problem to find the cross product, one problem to, find the equation of the line. So the exam should have 10 problems. One problem should be a problem which states, write down the formula, write down the concept, like define curvature, where you just write the formula in terms of S, right? Because you will be using the formula in terms of T if there is a curvature problem on the test. Now, if the curvature problem says calculate curvature and the problem gives you something that you recognize, you don't have to do calculation if you know the theorem. Remember that I wrote that the straight line has 0 curvature, the circle has curvature 1 over radius? Well, if you know these things, then you can just write the answer because you will be calling on a theorem that we previously had. There's no reason to reinvent the wheel. You just have the knowledge and you just use it, right? So that's pretty much what it is. So hopefully you will practice those post-tests, right? So chapter 13 and chapter 14, I believe. Right, we're chapter 14 now. Yeah. So chapter 13 and chapter 14 post-tests, those will help you pinpoint the issues that you have with whatever concepts. That grade does not calculate together with your quizzes. It doesn't calculate with your homework or anything. I actually don't get any reports from that because it's designed strictly for student practice. If you have any issues with basic integration or anything like that, use the study plan to go back and forth. If the homework is closed, again, don't panic. Study plan is the place where you go and you can practice 100% of the problems 24/7. We will start the new chapter tomorrow because we don't have the luxury of sitting around and waiting for exam to come about. We're going to do the lab now. Remember that the individual lab reports are not accepted, considered for grading, so you have to have a group. Minimum is 2. The best groups are groups of 4 and 5 because you have enough people solving the problems in the lab so you can actually compare. And that's it. All right. I will see you all tomorrow.